The traditional testing pyramid, with unit tests at the base and a few UI tests at the top, is a concept built for monolithic applications. Applying this single pyramid to a distributed microservice architecture is a mistake. We do not have one testing pyramid. We have two distinct functional architectures, the backend pyramid and the frontend pyramid. Let's break down the functional layers first. The primary goal of the backend is data integrity and service communication. Your base is fast, isolated unit tests, followed closely by integration tests to validate database queries and internal module behavior. The middle layer then relies heavily on API contract testing to ensure microservices can deploy independently without breaking downstream consumers. The front-end pyramid, conversely, relies on isolated component tests using tools designed for the DOM, moving up to state management with strictly mocked network responses. Full browser E2E tests are reserved strictly for critical user journeys. However, a robust architecture demands that we shift left on non-functional requirements. Before a single functional test runs, your CI pipeline must execute static code analysis and vulnerability scanning. This is the bedrock of your pipeline. By integrating static application security testing, or SAST, and software composition analysis, you automatically catch vulnerable dependencies and hard-coded secrets the moment a developer opens a pull request. If a critical CV is detected in a third-party package, the pipeline must fail deterministically. You do not wait for a security audit to find these flaws. You block them at the commit level. Furthermore, an architect understands that testing does not end at deployment. The apex of your modern QA strategy merges directly into production monitoring and observability. We execute synthetic tests, lightweight automated scripts that run continuously in production to verify that critical API endpoints and user logins are functioning in real time. By coupling these synthetics with distributed tracing, your engineering team can identify precisely which microservice is failing before a customer ever reports a degraded experience. This is where you must master the three pillars of telemetry: logs, metrics, and traces. Telemetry is no longer just an infrastructure problem. It is a core QA function. When a pipeline test fails or a synthetic check drops in production, you shouldn't be guessing. You shouldn't be wasting hours trying to reproduce the issue locally. Rich telemetry allows you to instantly pinpoint the exact microservice, slow database query, or failing third-party API that caused the bottleneck. To implement this advanced pipeline, here is practical architectural advice you can apply immediately. Rule 1. Optimize for the absolute minimum number of total tests. A giant test suite is not a badge of honor, it is a maintenance liability. Every single test costs you compute time and money, so ruthlessly prune redundant checks to keep your CI lean and fast. Rule 2. Enforce strict execution time limits. If your integration suite takes more than 10 minutes to run, it is poorly designed. Mock external dependencies aggressively to keep feedback loops lightning fast. Rule 3. Decouple deployments from releases. Use feature flags to deploy unverified code into production safely. This allows you to perform final validation in the live environment without exposing the feature to your users. A lot of old-school testers are going to hate hearing this. If you have more than 20 full browser E2E tests in your pipeline, your architecture is broken. High E2E coverage is a massive anti-pattern. If you are writing hundreds of Selenium, Cypress, or Playwright scripts, you are using slow, brittle UI automation to compensate for a lack of confidence in your unit contracts and backend observability. Stop trying to automate every visual edge case. Delete your massive UI test suites. Automate only the critical revenue paths and rely on feature flags and production telemetry to catch the rest. Thank you for watching. If you found this architectural breakdown useful, please subscribe to the channel and leave a like.